answers were in the back as you were looking at these. So if we are looking at number 6, in number 6, as you looked at the answer, you probably want to have your dosage here, and we're talking dosage in milligrams. And I would say, you know, if you're going up, I don't care if you go every 2 or 3, that you go 25. And so maybe if you went every 2, that's 25. This is going to be 50. This is going to be our 100. And 1, if we are looking at 75, 100 is our highest we were going to. So as you were looking at yours, then down here, what kind of scale did most of you decide to go with?
Yeah.
You're going from 9 pounds up to 27, right? So what did we use for a scale? Anyone use 2 or 3? To me, like 3 makes sense that I'm going 3. So 6, this would be 9. I have, and then you keep going. So that when I was doing that first one at 25, it has to be from 9 to 11 pounds, right? So this is going to be 12, this is going to be 15, so it's going to be a pretty small one with an open circle. Okay. The next one for 50 milligrams goes from 11. So at 11, I'm going to have a closed circle for 50 milligrams, and it's going all the way up to 17. Well, again, it's not that far that we were looking at with an open circle. So please just take a look at setting your scales. And I'm not going to be that picky on setting your scales as I look at number 6, but take a look at that answer key. And then I should have that next one also. It should be a closed circle. And in this one, you go from 17 to 22 pounds. So again, you're going to have a closed circle up to 22, which means when you are 22 pounds for this baby getting this medicine, because that's what you're talking about. Dosages, if we are looking at a child's weight in pounds, right? So this is probably a small infant that you're looking at giving the medicine. You don't want to give them too much of something. So if they are at 11 pounds, you should give them 25. Whereas if they are at 11.5 pounds, if we are looking, you're going to give them the 50 milligrams, right? That's what that dosage step tells us on the medicine. So that's what it's telling you as you look at that. And you should have one more up here. And I would say down here that you have this is your weight in pounds, okay? This equation, when you were writing it, number 3, I had a lot of people go, I'm not sure how to write it. What's the equation for this line? Y equals what? Y-intercept is? What's our y-intercept as you look at that? 2? What's the slope? Negative x plus 2, right? What's the equation for this line? Y equals just x, right? And it should not be a negative x. It should just be x plus 2, right?
Yeah.
Okay, so those are my 2 equations. And so once you have the 2 equations, when you look at putting the f of x, you're just writing the 2 equations. And then back here is your constraint, which is really your domain, right? So where does this first line, the y equals x plus 2, what's the highest it goes? To what value of x? This is when x equals 0, right at this vertical line on top of the y-axis. So if we are looking at it, because if we are looking at our circles, and the one on top here was a closed circle, and the one down here was an... At this point, were they both closed, or is the top one open? Oh, the top one is open in here. So this is an open circle. So this is for x is less than 0, and this is for x is greater or equal to 0. Because at this point, it was a closed circle. So this equation goes right here. And this equation goes here. Those are my 2 equations. So when I was looking at number 7, I have a bunch of people. You should be able to graph these in slope-intercept one. Y equals mx plus b. First equation. What is my y-intercept, my start? Start is 0, and I have people go 3 over 2. Is that up 3 and over 2? No, that's 3 divided by 2. 3 divided by 2 is 1.5. So you're going to go to 1.5 on your graph. what is our movement in this first equation? M equals 1/2. That means a rise of 1, run of 2. Could you also have gone the movement of just going up 1/2 and over 1 unit? Yes. Up 1/2 over 1 unit, up 1/2 over 1 unit. I am going to graph this line as if this back part, this constraint, wasn't here. So I am simply going to graph that line. Do you agree that that's where that line is? I'm simply graphing that. This is how the video showed yesterday, right? It said graph the line. We're going to graph the other line also. The other line starts at what point, that second line? It starts at a y-intercept of 0. What's the y-intercept? 0, 3. Remember, this is your start, okay? When you look at these, this is my start point. So this is in slope-intercept form, 0, 3. So I'm going up to 3. And what is my slope or my movement? Negative 1. 1 over 1. And negative slope, we know, has to go down. So I'm looking at a negative slope. Okay? So this morning when we were looking at that, I think you had positive slope. So when we are looking at this, down 1 and over 1. And I'm going to continue doing that, right? That's what the two look like. Pretty soon we're going to do systems of equations. When we get to this point, it said the constraint was at x right here. When x is less than 1, and this is where x equals 1, right? This is that vertical line, okay? So, for x less than y, it's the first equation. So that's one with the pink arrows. I'm not going to have this part of it, okay? I am not going to have this. This got erased because it was greater than 1. We only want less than 1 for this line. This line is my y equals negative x plus 3. And if it helps you to put the equations by it, 1/2 x plus 1.5, that was that equation. That one only went up to 1. And at 1, we only have this equation, which means we are crossing this part off, right? It's not up here. That's why they had in the back at 1, it goes to 2, and 2 is a part of both lines. So it's a solid circle there, not open. Okay? Good.
So, well, I have a question. Like this may be a bit off, but technically, like if they crossed over, that wouldn't be like a function. So will we ever have?
No, this is a function because this is.
But if they crossed over, so does the constraint make sure that they are a function? Is that why they have?
In this case, it does. That's why this is still a function. Because if we would have had this line and this line, and you have 2 of them, you can't really have 2 equations for a function. That's why they have to break it apart to the separate ones. Okay? All right. So, like I said, today we get into sequences, and the notation is just different. Okay? So, it's a different vocabulary. I don't think I've put up Quizlets for this. Someone was asking where are the ones on absolute value and some of those other ones. I have put some of those up, but I haven't put this one up. So, when we think of a sequence, have you guys seen sequences before? Like the list of numbers like down there, the examples? You take a look at those, right? If you've had on your standardized tests and some different things you've seen, where you have a list of numbers like these examples right here. So when we are looking, a sequence is simply an ordered list of numbers, and often they have a pattern. Now we have 2 types of sequences that we're going to deal with. In this unit, we are only going to deal with what's called our arithmetic sequences. So, ordered list of numbers, often in a pattern. Each number is called a term, and we're going to have a special notation that we use for that, okay? So when you look at these, it looks like, could you tell me your first term in this one? Term 1 is what? Term 1 is 2. If I asked you for what's the second term, term 2 is 4. What does it look like the common difference is? What are we adding each time in that first one? So if I was asking you for the difference or common difference, so these are words that we're going to use in this unit. The common difference was 2, right? Or plus 2. if I was looking at this one, my first term is 3, second one is 6, third is 12. What's the common difference of this one? This one, it doesn't have a multiplying difference, or doesn't have an addition difference, right? It's doing multiplication, okay? We'll do ones like that later. And this one is a very special sequence. Anyone recognize this?
Fibonacci.
This is Fibonacci. And this is where you add the previous one, okay? So I have a poster back there, and so this is the type that we are going to be dealing with mostly today, okay? And what Fibonacci does is it says, and you see this in nature a lot, it's always adding the previous one. So 0 plus 1 gives us 1, 1 plus 1 gives us 2, 2 plus 1 gives us 3, 3 plus 2 gives us 5, 5 plus 3 gives us 8, and always the 2 previous ones add to get the next one, okay? I'm sure you could check it out. There probably is one. So, it says, look at these rectangular numbers. Write the first 6 terms in this sequence. So, the first one has how many dots? So this is my first term down here. So I'm going to use a different color. I'm going to use blue. First term has 2. What's the next term have? 6. The next one is a 4 by 3, which is 12. And the next one is if we're going across, right? We got 5 by 4, so we got 20. And if we were going to continue that one, we would have the next one being 30. So we got 1, 2, 3, 4, 5. After 30, we would have what? 42. So we want to think of, is there a pattern? And here is what they show for the pattern. They say if you take the height 1 by the length 2, right? 1 by 2. The next one is going to be 2 by 3, 3 by 4, 4 by 5, 5 by 6. That's one way of writing the pattern. So I just want you to be aware that when we look at this, this is one way of explaining this pattern to me. So please put this down, that first part up to there. Okay? 1 times 2, 2 times 3, 3 times 4, 4 times 5, 5 times 6. That's why some of you are very quickly able to go 42 and maybe keep going with that. Okay? This does continue, so we're going to put a parenthesis or a comma and then those dots. The other way of explaining the pattern is the second way. So in your homework, if you don't see a pattern like of multiplying, you might want to say you start with 2, you add 4, then you add 6, then you add 8, then you add 10. And sometimes you might not see that pattern right away, which is okay. So if we are looking at this, we want to make an ordered list. So this was the 1, okay? This is the 2, this is the 3. That's our n, okay? The number of dots, if we are looking at that, that's what's going to go here. Those are our numbers in our sequence, right? So as you're filling this table in, the first one at 1 was 2. Then you had 6, 12, okay, 20. If we are looking at that one, we should have 30. Remember, we said the next one, 42. If we continue that pattern of multiplying, we just took 6 times 7. So this one should be 7 times 8, right? So we're going to have, if we continue, we're going to have 56, then 72, and 56, and 72, and, oh no, yeah, 90. Okay? So, yes. If we are looking here, it says write these as ordered pairs. So as a set of ordered pairs, the first one is going to be 1, comma, 2. Okay. So is this set of ordered pairs, if we are looking at it, 1, 2, 2, 6, is this going to be a function?
Yeah.
Does each input give us an output?
Yeah.
It doesn't ask if it's linear, it says is it a function?
Yeah.
Yes, this would be a function, right? Each input has one output. What is our domain? Remember, domain is our values that we are looking at here of our n? Do we have any negative numbers? No. Do we have 0? No. We start with 1. Those are called our counting numbers, so our domain is considered to be our counting numbers. So how many dots are needed to make the 10th figure? So if we look at that table, and then it says, let's model an expression. So if you were looking at this, I like to think of that pattern that we set up above. So 1 times 2 gave us this. This was 2 times 3. This was 3 times 4, right? So if we're going to do the 10th one, we are taking what? 10 times 11. So if I was going to do the nth one, so you can multiply 10 times 11. 10 times 11 gives us 110. But this one says come up with an expression to model this, okay? And this is our new notation. You're going to use this, a to the n, a sub n, a sub n, equals, what are we always doing? We're taking the 2 times 3. We're taking the 3 times 4. So if this is n, if this is the 10th one, how do you get the 11th one? What do you do to the 10? Add what? 1. So we're going to write it this way. Okay? N times n plus 1. So a to the n, how do we always get that? We take n times n plus 1. So if I wanted to find the 20th one, right? They ask us to find the 100th. If I wanted to find the 20th number of this, I would say a to the 20, notice I put that as my subscript, is equal to 20 times 21. My calculator. This one said the 100. How are we going to find the 100? We're going to take a to the 100, a sub 100 equals, I'll get your question in 1 minute, 100 times 101. Why did I put 101? Because I took in here, if you wanted to write it, I could have written 100 plus 1, right? That's what this is saying, which is just really 100 times 101 on your calculator. What'd you get for a to the 100? Should give us 10,100. Frickin' question.
For like the a to the 20th.
Mm-hmm. So 20, and then I put 20 plus 1. So I take 20 times 21. That would give me the 20th term. This is just a notation. This is just you saying the 20th term. It's just a notation. So it's just a different notation. Instead of saying it as an ordered pair, this is sequence notation. Another mathematical notation you need to learn. Okay? All right. So, top of the next page, it asks us to draw the first 4 triangular numbers. So triangular numbers, the first one is just going to have 1 dot. Okay? My second triangular number has to have 2 on the bottom, right? And that's our triangle, right? Triangular number, okay? The last ones were rectangular, right? So the next one has to have 3 dots across the bottom, right? So draw the first 4, and we want to see if you can find a pattern. So the first one was 1. The second one had 3 dots. The third one had 6. What did you have for your 4th triangular number? 4 on the bottom. And then we have the 3, the 2, the 1, right? So 10. So anytime we're looking for patterns, I want you to see if you can start seeing any patterns yet. See if you can fill in your table. Okay, so how did I get this 1? So remember, when I look at this, these numbers here are my numbers going across here. That's all those are. Okay? We don't want to draw any more than that. The number of dots, if we are looking at that, the number of dots, that came from here, and then the 3, right? So we want to start looking for a pattern. If we are looking at this, one thing I might start doing is I might say, you know what, I can add something. 1 plus what gives me 3? 2. I add 2, right? So I can add 2. 3 plus 3. I can add 3. 4. I'm adding 4, right? So I could have 15, and if I wanted to continue that, right, I added 5. So 21. Then I should have 28, right? 36 and 45. Added 6, right? Added 7, okay? That's one way of looking at it. We want to be able to come up with our nth number in this. Now, that gets a little tricky because if we are looking at this, we want to continue this so that this pattern continues all the way down to the nth number. So we might want to look at, is there a different way? And one thing I like to think about is, how do you find the area of the triangle? Base times height divided by 2. So if I think of my numbers, and I think of here, and I think of, oh, what if I go with 1 times 2, and I divide it by 1 times 2, and I divide it by 2. Does that give me this? Okay. So what if I take my side, 2, and I go to the next number bigger, 2 times 3, and I divide it by 2. Does that give me my number here? 2 over 2 is the same as 1, so that's 3. So now I'm going to take this number 3. So kind of like the last one, 3 times 4, one number bigger, divided by 2. 12 divided by 2, is it 6? Okay, it's a different pattern than adding. Okay, you are taking the number here times the next one. So 1 times after 1 comes 2 divided by 2. It's kind of like area of a triangle. So if I try that for the 6th number, take the 6 times the 7, the next one, divide by 2. 42 divided by 2, does it give us 21? Please try it for the 8th and 9th one to see that my pattern works. So you're going to write to the side, 8 times 9 divided by 2. Does it give you 36? 9 times 10 divided by 2. Does it give us 45? So sometimes this addition of a different number, okay? So when we are looking at this one, this is how they're writing this pattern, okay? They're going to say, when we are looking at this, a to the n. So if we were finding our nth one, it is going to be n times, so the number plus 1 more, that's when we did 9, 1 more to 9 is 10 divided by 2. And this is how we could find, if I say in this pattern, what is the 50th number in this pattern? How many dots would I have to have in the 50th triangular number? If I was looking at the 50th triangular number, right? That means I'm looking for a of 50. I would have to take 50 times 51 and divide it by 2. 2 divided by 50 is 25, right? So 25 times 51 would give us our number. Okay? What do we got? 25 times 51. Someone want to put it in and multiply it for us? Say it one more time. 1,275. Okay? Notation, looking at patterns. So here's a lot of vocabulary, okay, as you are looking at this. So today's is mostly vocabulary. So we use a special notation. Function notation was used for our functions. The 10th triangular number would have been 55. Therefore, we say the 10th term in the sequence is 55. We write it this way. T sub 10, meaning the 10th term in the sequence is 55. T sub 10 equals 55. The little number 10 is called our subscript or our index. It is not to a power. It is the subscript or index. It just tells you the position of the term. This is the first term. This is the second term, third term, fourth term. Okay? So sequences are functions. So my hint is after you, tonight, when you go home, reread this page. Go back to this page a couple of times. Keep your head up, please. So when we are looking at this, go back to this 2 or 3 times and go over it. A sequence is our functions. Domain is our natural numbers. Okay? You can represent them using function notation or sequence notation. So here is your sequence notation. That's what we're mostly going to be worried about. T sub n times n plus 1 over 2. The function notation is written this way. So in a function, if we are looking at it, f or t, independent variable x, in our sequences, they usually use n. T sub n just means the nth term. It is simply a lot of different vocabulary than you've seen before. So we're going to be talking about 2 different kinds of formulas, explicit and recursive. Explicit is the first type that we're going to look at. It says this formula that we came up with for the triangular numbers is an explicit formula. When we look at explicit formulas, because we can use them to calculate the nth term directly or explicitly by substituting in n. This is very nice way of starting out if you look at our equation. It says I named the sequence t because we're talking about triangular, right? A lot of times we're going to use A because we're talking about arithmetic sequences. Does it matter what the number out in front of the letter is? No, it's just a lot of times whatever you're kind of talking about. So it's because we were talking about triangular numbers, thus the T. Okay? So what if we were trying to find the 20th number in our triangular sequence? So we're going to go to T sub, and what we're really looking for is T sub 20. What is that going to be equal to? 20 times 20. If I'm writing it exactly from the formula, I'm going to put 20 plus 1, all divided by 2. Well, really, that is 20 times 21 divided by 2. I don't care if you multiply first or if you divide. To me, I think 10 times 21 is a lot easier. 210. Not hard, just a different notation, right? Just looks different than what we've had before. Okay? So, in this one it says, consider the squares of natural numbers. So, 1 squared is 1. 2 squared is 4. Fill in your table, please. 50. So, t to the 250. Well, our formula was, in this case, t to the n was equal to n squared. So on your calculator, we're going to take 250, right? And we are squaring. 25 squared, anyone know?
No, it's way over.
62,500. 62,500. 250 times 250, right? 250 squared. Okay? We got a little more notation that we got to finish. Top of the next page. Recursive formulas. Okay? Recursive formulas. You're going to see something written like this. T to the 1, that's your starting value. So a recursive formula tells you the first term and it tells you the rule. This one is going to be the expression showing you what to do to the previous term to get the next one. Usually we show a previous term as t to the n minus 1. Now I always have students think I have to take and subtract 1 from something. You don't. So in this sequence where you have 40, 20, 10, 5, 2.5, here is the recursive formula. You started with 40, that's your first term. And each term, it looks like we are dividing by 2. We're taking it time a half, right? So previous term divided by 2. That's how we could write it out in words. Mathematicians, we don't like to write it in words. We want to make it shown like in notation. So t to the 1 equals 40. T to the n, this means previous term. That's what this means. But instead of writing out previous term, I can just put t to the n minus 1. That means previous. That's all it means. And I'm dividing it by 2. Okay? So, last bit of notes. So it says to repay a $200 loan, you're going to make a payment of $20 at the end of each month. You receive a statement telling you how much money you owe. If we are starting off with this, we're going to write this as each term. So t sub 1 is not going to be 200. At the end of the first month, how much do you owe? 180. So t sub 1 is 180, right? Because you had a $200 loan you've already paid off at the end of each month. So first month, you paid off. Please tell me it asks for, well, let's go with the first 6, I think it says. List your outstanding debt for the first 6 months if we're looking at this. So we have t sub 1, t sub 2 is going to be 160. T sub 3, subtract another 20, 140. T sub 4, 120. T sub 5, right? So it just means telling me the terms. And t sub 6 is going to be 80. If we are looking at this, it says write a recursive formula. So recursive formula means I have t to the 1, and I'm going to put this bracket out in front. Some people kind of freak out when they have to write the bracket. It doesn't have to be perfect. And then t to the n. My first term was 180. How do I get the next term? I take the previous. This means previous. Keep that in mind. I just don't want to write out this word previous, right? T to the n minus 1. And I'm doing what? Subtracting 20. And then you have to put this for values. It's kind of like our domain. For values n greater than 1. You cannot use 1 because you already used 1 up here. So this is, you're going to tell me for the second term, for the third term, for the fourth term, okay? So we're going to write a recursive formula for each of these, okay? I want you, with your shoulder partner, to write down what is your first term, and then we're going to put t to the n. So right now, just with your shoulder partner, check that you got your first term, and then try and tell me what's happening. Like, what are you doing to get the next number, okay? That should have been 7, right? In the second one, our first term was -2. In the first one, if I was going to ask you what is happening, Jack and Mallory, what would you tell me? We are taking everything times 3. To get the next thing, we're multiplying by 3. Dylan and Brecken, how about in the next one? What are we doing? To get our next number, what are we doing? Did you guys look that one yet? Adding 5 each time, right? So, in this one, t to the 1 is 7. Our next one, we're going to put t to the n minus 1. And what were we doing with that? We were taking it times 3. And when we write that, we're going to put 4 n greater than 1. And I'll show you how you can check it. Down here, we're going to put t to the n minus 1. That means previous term. This just means previous. That's all this means. Okay? And what are we doing? We are adding 5 each time. For n greater than 1. So if I wanted to check that, this is my fourth term, right? T sub 4, right? If I was, so let's start with our T sub 2 here. The second term, it says take the previous one. What was previous to this term? -2. And add 5. Does it give us 3? Okay. If I would look at the third term, I take the previous one, which was 3, and I'm going to add 5. Does it give me my next term? Yes. So that works each time. Okay. This is not a good way to find a bunch of numbers. This is called a recursive formula. So this is what your assignment looks like. So I want you to look at question number one.
Are you?
So back on page 56. Okay? It is 2 pages. Okay? 56 and 57. So as you look at the first one, it says, what does g of 5 equals 162 mean?